All right, 2.2, change in linear and exponential functions. Here we go. Asher.
In the last section, we learned that arithmetic sequences behave like...
All right, so arithmetic sequences behave like what kind of functions? Linear.
They behave like linear functions, and that geometric sequences behave like...
All right, so geometrics behave like what? Exponential functions. What makes an exponential function exponential? The variable is your exponent. All right, fantastic. Keep going.
We will look more closely at these connections today.
All right, so let's talk about arithmetic and linear functions. They fit the same form, okay? And so your b and your a sub 0 are the samesies. Your slope is basically a common difference. And then we mostly use what's called point slope form, or this general form of the arithmetic. When we talk about geometric, it fits like an exponential function. And so when we talk about those, my ratio is kind of like what grows. It's what's being multiplied. Most of the time we're looking at this general term of it. Go ahead.
It is important to recognize and understand the similarities and differences between linear and exponential functions.
Sure is. All right. So a linear function is when we have equal input values, the output values change at a constant rate. All right. So my first differences are constant. We have a what kind of function? A linear. And in exponential functions, the input values are equal. The output values change proportionally. It changes at a constant proportion. All right. And so proportionally usually means with a fraction. So it's multiplied by that same fraction over and over. A linear function is what you add from term to term. Okay, even though the equation is multiplying, it's from adding from term to term. In an exponential function, you're multiplying from term to term, and that's why it's exponential. All right, keep going.
If you have 2 points, you can write the equation of a linear function, exponential function, arithmetic sequence, or a geometric sequence.
We can do it all. All right, here we go. Example 1.
Select values of several functions are given in the table below. For each table, determine if the function can be linear, exponential, or neither.
All right, fantastic. So we need to make sure our input values are equal. And once we know our input values are equal, we can kind of just work with our output values. So instead of going like, hey, 7 to 5 is negative 2, and then we divide it by 3, yes, the average rate of change is negative 2 over 3. However, do you see the input values? Like they're all gapped by 3. Okay, we good there? All right, so then we can just work with the outputs. All right, so 7 to 5, how do we get there? Negative 2. How do we get there? Negative 2. How do we get there? How do we get there? So what do we know the function is? Linear. All right, pretty good. Cool, we're moving. Part B. So again, we need to look at our input values. So I got 1, 2, 3, 4, 5. And so are we equal gapped? Good. All right, and so now we just look at our input values. And so, or output values. So 0 to 1 is 1 and then 3 and then 5 and then 7. So is that linear? No. So now let's try to do the multiplication. Let's see if it's exponential. So 0 times what gives you 1?
0.
Nothing. So is it exponential either? No. So for the sake of this worksheet or notes, this is neither. All right. What do we know this function is, though? This is quadratic. Why do we know it's quadratic? The second difference is constant. The first difference is linear. The change in my change is constant. All right, cool. Let's look at part C now. So my inputs, 0, 2, 4, 6, 8, are those equal inputs? Good. So now let's look at our outputs. So 1 to 2, how do I get there? Plus 1. All right, and then
Plus
2, and then 4, and then 8. And so is it linear? No. So now let's try to multiply. So how do I get from 1 to 2?
2.
Times 2. How do I get from 2 to 4?
Times 2.
Awesome possum. And then what?
2.
Awesome. And then what?
2.
Cool. So what do we know that is now?
Exponential.
That's exponential. All right. Let's look at D now. So are my input values equal gapped? 5, 10, 15, 20, 25.
Yes.
All right. Who else felt like a boss when they learned how to count by 5s? Yeah, you did. All right, Robert learned last week. That was good. All right, and so then 80 to 40. Is this linear? 80 to 40, 40 to 20. No, it's not linear. We can just kind of do an eye test on that one. So let's see if the multiplication works. So how do I get from 80 to 40?
1/2.
Times 1/2. And then how do we get from 40 to 20?
1/2.
Awesome. And then what?
1/2.
So is it going to work?
Yes.
Yes. So what do we know it is?
Exponential.
It's exponential. We love Robert, don't we? Yeah, we do. All right. That's in the recording, bud. I'm still going. All right. Example 2.
A wild rumor is spreading that Mr. Passwater won 3rd place in the world's strongest man contest.
Sheesh.
Mr. Passwater probably didn't start the rumor. The number of people that have heard the rumor can be modeled using a geometric sequence, where the 43 people had heard the rumor on day 3, and 140 people have heard the rumor on day 6. According to the model, how many people, to the nearest whole number, have heard the rumor by day 10?
All right, fantastic. So what kind of sequence is it? Geometric. That's going to help me in how we do this problem. All right, and so then it says 43 people heard the rumor in day 3. So that kind of gives me an ordered pair. And so this means G sub what? 3 is equal to 43. And then I'm going to break it down more. 140 people heard the rumor on day 6. So that means what? G sub 6 is equal to 140. And so then we need to figure out at the rumor by day 10. So G sub 10 is equal to something. That's what we're trying to find. All right. And so if it's geometric, what do we need to find? Our ratio or our difference? Our ratio. So that's what we need to do, kind of what we did today. Some people did it on their board points. And so we're going to do our last one. And so we get 140. And so is equal to what? 43. And then my ratio is going to be used how many times? 3. Why is it 3? Because it goes from 3 to 6. All right. And so now I need to solve for my ratios. So first I do what? Divide by 43. So now I have 140 over 43 is equal to r cubed. Now how do I solve for r? I cube root it. So now I have r is equal to the quantity of 140 over 43 to the power of 1/3. And just leave it like that. Because if we actually use our calculator right now, we're going to round in a decimal. And then if we use that rounded decimal, we're going to be off later on. So we're just going to use whatever number that is, whatever that might be. All right. Now, we actually need to build our G sub n first. So let's build our G sub n. So which one do we care about using? It doesn't really matter. Which one do you want? 6. Let's do it. And so now I start out at what? 140. And then my ratio is 140 over 43 to the power of 1/3. And now I'm going to raise that to a power of what? N minus 6. All right. And so now all we're going to do is we're going to substitute in 10 because we want to know after the 10th day. All right. And so now we're going to assign G sub 10. So we got 140 times 140 over 43 to the power of 1/3 times 4. So now we get 675.5759. However, in the directions, it asks for what? To the nearest whole number. So now we're going to round to 676 people. All right. Asher, go ahead.
A large theater has rows of seats where the number of seats in each row can be modeled by an arithmetic sequence. If the 5th row has 31 seats and the 11th row has 49 seats, determine how many seats there are in the 25th row.
All right, so let's break it down. So what kind of sequence is this? Arithmetic. Okay, that's going to lead how I'm doing this problem. And so the 5th row has 31. So how do I write that? A sub 5 is equal to 31. And then it says the 11th row is 49. So I'm going to say what? A sub 11 is equal to 49. Now, I'm going to use it this way to find my common difference. If you wanted to, you could build your A sub n kind of way. I personally use this way. And so now, what's my difference? 18. What's my difference in terms? 6. So my common difference is 18 over 6, which is 3. And so from there, let's build our A sub n. And so a sub n is equal to what? Which one do you want to use? It doesn't matter.
11.
The 11th one. So we get equals 49 plus my difference of 3 times n minus 11. And so from there, what do? We just find our a sub 25. So we're going to find a sub 25. So we got 49 plus 3 times 25 minus 11, which is 14. And then 14 times 3 is 42. 42 plus 49 is 91. All right. And so our 25th row has 91 seats. All right.